Hello everyone. The final video of today's lecture is just about some other useful instructions that you might need in RISC-V programming. So the first thing I want to go over are the RISC-V arithmetic instruction multiply extension. Specifically, I want to point out that this is an extension, which means that this is not necessarily going to be guaranteed to be supported by all RISC-V CPUs, though most of them will in general have this extension in it, as it is very useful. So the first operation I want to cover is the multiply operation. Notice that there's two different operations there. There's mul and there's mul-h. The reason why we have two is because if you think about it, if I multiply two 32-bit numbers to each other, the maximum value that I can get is a 64-bit value. Because of this, we need to get two operations, or we need to have two different operations to extract either the lower or upper 32 bits of this multiply. You can see that here we have mul, which gets the lower 32 bits, and mul-h, which gets the upper 32 bits. We also have division, which will take two source registers and it will divide source 1 by source 2, and we can also get the remainder if we want to as well. The next set of instructions I want to talk about are some of the bitwise operations. So I just wanted to point out that just like C, we have some of the normal operations where we have AND, OR, and XOR, and we have the immediate versions of them versus like a variable or register versions of them. The next operation I want to talk about is set less than and set less than immediate, aka the immediate version is the cousin of just set less than. So this is a really cool operation. It takes in two registers and compares to see if the value in register 1 is less than the value in register 2. If this is true, that means that we're going to set the destination register to 1. If this is false, we're going to set the destination register to 0. This is actually very useful, and I want you to think back to what type of control flow might this be useful for. Hint, that was the word, control flow. So let me bring back the idea that we had with our branch instructions. Say we only have the operation branch equal to, and we want to perform this if I is less than j operation. We could actually use set less than to accomplish this. As we can see here, we're checking to see if S0 is less than S1, which is what this operation is. And if this is true, we're going to set this to 1. So what this is checking for is if we've set it to 1. Because if we've set it to 1, that means that it is true, so we want to go into this then block. But because we're checking that it's equal to 0, that means that we don't want it to be less than. So it's either greater than or equal to, and that's why we're jumping to the else block for this branch. This is just something that's kind of important for you to know, as some assembly languages actually do not have the different types of branch comparison that we have. There are some assembly languages that you'll do a comparison operation as a separate instruction, and that instruction will set a flag essentially within your CPU to tell you if I perform a branch operation, then I am going to take the branch. So this is the method that you would actually do that in RISC-V, though RISC-V doesn't really have that, so in general it's bad practice to actually do a set less than to do your comparison and then a branch based off of that. You should just use the branch less than or branch greater than or equal to if you need to do those type of operations. The final instruction I want to go over are environmental calls, or eCall in RISC-V. So an eCall, or environmental call, or syscall, is a method of the application interacting with the operating system. There are privilege levels and all this kind of stuff that's trying to protect the application, and it's also trying to protect the operating system, and this is the method to actually communicate between that barrier. So you might have an eCall as a single instruction in your code. And eCall doesn't take in any arguments because it's just a single instruction, but it will use the values in like register A0 and A1 and all that to tell it what it wants to do. Since eCall does not take in any arguments, and since it doesn't take in any like extra parameters and such in the actual instruction, and it is given based off of the values in the register, eCall needs a method to determine which type of operation should the OS perform because you called eCall. And in this case, in Venus at least, we use the register A0 to determine which operation we want to perform. For example, do we want to print something to the screen? Maybe we want to exit the program. Maybe we need to allocate more space. A0 will hold the value, which is essentially selecting which operation we want to perform. If you want to look at all the eCalls that Venus supports, you can actually click on that link right there, and it will take you right to it. There are a bunch of eCalls that are supported, though do note that it is Venus specific, and they're not all the same as what Linux is. For example, Linux actually uses the register A7 to do its selection of which function it's going to call, as opposed to Venus, which uses A0.